Today we're going to look at Chapter 2, Statistics, and then also Chapter 5, we'll look at logarithms and power functions. So Chapter 2, we looked at mean, median, and mode, and that actually will not be on the final, so we'll skip that. Standard deviation will be on your final, not the actual calculation, but you have to know the meaning. So if we talk about the meaning, let's say, for example, we had two students. How about Al and Ben? And let's say we looked at the scores for their tests, and we looked at the standard deviations of their scores, and let's say Al had a standard deviation of his test scores of 2.4, and Ben had a standard deviation of 5. What that means is, on average, Al's are less spread out. His test scores are on average 2.4 away from the median, or the middle, the mean, and Ben's are on average about 5 away from the mean. So Al's scores are more consistent, less spread out, and Ben's are less consistent or more spread out. So they're more spread out. He could have a few A's, a few C's, maybe an F or so, and maybe Al is all C's. So that's what standard deviation means. It's the average distance from the average. A box and whisker plot, you'll have to know what everything stands for. So let's say we have this box and whisker plot right here. The min is the smallest value, the max, and then we have Q1, we have Q3, and then we have the median, which is also called Q2. All right, this is your 5-number summary. To find it, you'd put your numbers in order. So let's do it with these numbers. We have 1, 4, 4, 6, oops, I forgot a 5, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to find your 5-number summary, we have our min and our max. That's pretty easy, min, max. Our median is the middle, so you cross off until you get to the middle, and it looks like our middle here would be 5.5. So there's Q2. And then we look at Q1. Q1 is the middle of the first half of data. So here, we don't count the 5.5. You never count the median. When you look at the first half of data, you look at everything below that. And it looks like Q1 is 4. It's the average of 4 and 4. And then we're going to look at these numbers to find Q3, and Q3 would be 8.5. So Q1 is the middle of the first half of data. Q3 is the middle of the second half of data. Percentile rank is the amount below you, so the percent below. So let's say 2,000 students took a final in pre-calculus. The highest score of the exam was 88. What percentile rank is associated with the score? If you got the highest score, then there's 1,999 people below you. So you're in the 99th percentile, I believe. Let me double check. 1999, whoops. Yeah, you're in the 99th percentile. So the higher the percentile, the more people that are below you. So if you're talking about test scores, you want to be in the 99th percentile because it means you got the best score. So there's percentile rank, the percent below you. Skewed means more spread out. So this graph right here is skewed to the right. It's skewed to the right because think about those little like Arby's sauce packets or the ketchup packets. If you squish it down on the right, it's more spread out. You're spreading out the sauce. So this is squished down on the right. It's skewed right. Let's look at another example. Oh no. Hold on, my Mobi's not working. Let's restart. Okay. Okay, so now let's do, oops, I don't want that. Let's do, okay, so I was on skewed. All right, so this is another example is of skewed right, because it's squished down on the right, or you can see that more data is spread out to the right of the median. This is skewed left, because it's squished down on the left right here, or it's more spread out to the left of the median. So they're skewed, more spread out to one side or the other. If it's not spread out, then it would be symmetric. All right, normal distribution. The middle is right here, and then it's separated in by standard deviations. So in class, we just made a chart right here. So if something is normally distributed, then the average is the same as the median. Average is x bar. And then we look at something one standard deviation away. You can see that most of the data is one standard deviation away. So this is 1 SD, I'll call it. And if it's one standard deviation away, it's 34% or 34% on each side. So 34% of the data is above the average, one standard deviation away, and 34 is below. And 68% is within one standard deviation. So if we're talking about like the heights of children, you would have an average height, and 68% of the people would be within one standard deviation from the average height. And then you go out to 2 standard deviations and it drops. So this is 2 standard deviations. And this is 13.5%. And it's always defined a little bit differently, so you might not see these numbers exactly, but we call it 13.5% that are 2 standard deviations away. Then you have 3 standard deviations away, and this is 2% on each end. And then you have 0.5 that are 4 standard deviations away, and this is 100% of your data. So let's apply it to a problem. So it says the weights of 1,000 children were recorded on their first birthdays and distributed normally. So the average is 10.3, and the standard deviation is 1.6. So if we go out one standard deviation, we're going to add 1.6, so this is 11.9. And we're going to subtract 11.6, so we're going to take 10.3 minus 1.6, and we get this is 8.7. And this is 34% of our data and 34% of our data if it's normally distributed. And we go out another standard deviation away, and again we add 11, oops, I'll subtract first. So this is 7.1, and if I take 11.9 plus 1.6, this is 13.5, and this is 13.5% of our data, 13.5% of our data. All right, and then if I add 1.6 again, this is 15.1. And if I take 7.1 minus 1.6, this is 5.5. This is 2%, and this is 0.5. All right, so we're going to use this chart to answer the following questions. What is the probability that a randomly selected child will weigh less than 10? Let's do 10.3 kilograms, so let's change that. All right, so we look at our chart. Less than 10.3 would be this half of the data. So if it's asking about probability, it's a percent, and 50% is less than 10.3. What is the probability that a randomly selected child will weigh between 8.7 and 11.9? All right, so 8.7 and 11.9 would be 34 plus 34, 68% of the children would weigh between 8.7 and 11.9 or be within one standard deviation. How many of the children would you expect to weigh? So how many means how many total children, not a percentage. And let's do, to make it nice numbers, let's do between 8.7 and 11.9. So again, 8.7, 11.9, that's 68% of our data. So if it's how many, we change the percent to a decimal, and of means multiply. So 68% of 1,000, you multiply and you get 680 children. How many of the 1,000 children would you expect to weigh more than 8.7 kilograms? All right, so here's 8.7. How many are more than that? So here's 50% plus 34%. So you have 50 plus 34. That's 84% of the children are right here. So against how many is multiply? So 0.84 times 1,000. And that would be 840 kids or children would weigh more than 8.7 kilograms. All right, this is freezing, sorry. Types of studies, we have experimental, observational, and survey. So I will ask you on the final what type of study is this, and you have to be able to identify, so you can read through those. Here's an example. What type of data collection was used? Bias or misrepresentation. One major form of bias or misrepresentation is the scale of the graph. So let's say that one day the temperature was 50 degrees, and the next day it was 60 degrees. Well, the misrepresentation in this graph would be, all right, 60 is not double 50. So if graphs don't start at 0, that's a big source of misrepresentation. Okay, so there's a summary of Chapter 2. Let's take a look at Chapter 5. Okay, so we have to know exponential growth and decay. So growth is when you have your starting value times b to the x. So a is your start, b is your rate, x is usually time. So growth is when b is greater than 1. Here's what growth looks like. Decay is when b is less than 1. And again, you see a lot of this in population growth or decay. So there's what decay looks like. You have to know how to solve exponents. So for the first one, simplify, break it down piece by piece. So if you simplify 4/6, this is 2/3. If you have 5 x's on top and 6 on the bottom, when you cancel, you have 1 x left on the bottom. If you have 11 y's on top and 7 on the bottom, when you cancel, you have 4 left on the top. If you have a power to a power, distribute, or you could write it out. This is 2 to the 4th, x to the 4th, y to the 12th. So if it's a power to a power, you multiply. And then if you simplify, we get 16 x to the 4th, y to the 12th. And then if you have negative exponents, you can flip them to make them positive. This is b squared over a to the 5th. Okay, logarithms, knowing how to use them. Here's an example. You buy a car for $4,000. The value of the car depreciates by 20% a year. When will it be worth half of its value? You can use guess and check, find a common base, or use logs to solve if x is the exponent. Let's use a log. I'll divide. So you get 0.5 equals 100% minus 20% is 80%. Here you could use guess and check. I would just use a log. The base is 0.8, and then remember to loop it around. So log base 0.8 of 0.5 equals x. And then you type that in your calculator to figure out how long will it take to be worth half of its value. Okay, so again with logs, if x is the exponent, you can use a log. This is log base 5 of 1 over 25, and you could type that in. This one, divide by 5,000 first. You have 1/5 equals 1.03 to the x. This is log base 1.03 of 1/5 equals x, and you just type it in. Now, the bottom 3 are power functions, so you have to use reciprocals to solve. Let me take a screenshot. Okay, so this is where you use opposite order of operations. So for the first one, we'll divide each side by -2. We have x to the 5th equals -25. To get rid of something to the 5th power, you can take it to the power of the reciprocal, take it to the 1/5 power, and type that in. Or some people like to take it to the 5th root, so another way you could do it is take it to the 5th root. And you could get your answer that way as well. For the next one, to get rid of the 8, you take it to the 1/8 power or to the 8th root. So take it to the 1/8 power. Or you can use this radical sign with the 8 in front. You have x minus 2 equals 2, and you add 2 to each side. Now remember, if you have your multiple choice test, you could take all your answers and plug in and see which side gives you 256. All right, for the last one, let's change this to radical form. To change it to radical form, the number on the outside of the radical goes on the bottom, and the number on the inside goes on the top. So this one will subtract 5 from each side first. X to the 1/3 equals 12. And then to get rid of the 1/3 power, we take it to the power of the reciprocal, or take it to the 3rd power. And so x will be whatever 12 to the 3rd power is. 1,728 maybe? Last thing, composition of functions. Let's do f of g of x first. So here we start with the inside function g of x, which is 4x, and plug it into x. So this equals 4x, and then you still have the plus 2. Let's do g of f of x. This time we take f of x, this right here, and we plug it into x in the g function. So we have our 4, and then x plus 2. And then distribute, we'll get 4x plus 8. And there's your answer. All right, so there it is. And you can watch the first podcast for the first chapters that we did this semester.